For our last master class video, the topic will be about length of curve, surface area, and the third is the centroid. First is we will discuss about the length of a curve. For example, this will be our graph with the line here, as if we have a line here, and let's say this will be A and this will be our B. If this is our line, we will find the length somewhere here. It should be look like this. The length of the curve should be look like a triangle. And this part, this will be our dx. The height of this will be our dy. And the line here will be our dl. This will be our y. Oh, that's y. It should be y. And here will be our x. So let's extract this. This will be our dx, our dy, and our dl. dl squared equals dx squared plus dy squared all over dx squared. Plus dy all over dx squared. This is how we derive our formula. We will cancel this out. dl all over dx is equal to square root of 1 plus y prime squared. The derivative of this will be dl square root of 1 plus y prime squared. Our final formula to get the length of a curve is 1 plus y prime squared dx, and our limits should be a to b. That's it. This will be our formula on getting the length of a curve. This formula is divided by the dx, and the limits is along the x-axis. dx. This will be our second formula. Squared dx all over dy squared plus 1 rdl x prime squared plus y dy length the integral of 1 plus x prime squared dy. Our limits is from c to d. This is our second formula on getting the length of a curve. This formula is just applied when it is divided by dy and the limits is along the y-axis. This formula is along the y-axis, and this formula is along the x-axis. This will be our problem in getting the length of a curve. Number 1 is find the length of the curve, which is y is equals to square root of x from x equals 0 to x 5. First is we will draw a line here, since this will be a parabola. Do it like that. And our limit is here to here. So let's say we will find our length of curve from here. This is the end, so we should. That's it. So this will be our dy, our dx, and our dl. This is our y. From here to here will be our x. Let's extract this, our triangle, dl, dx, dy. Our y is equals to x. To derive this, our y prime will be y all over. Since this problem is along the x-axis, we will use this, our first formula. L is equals to the integral of b square root of 1 plus y prime squared dx. This is the formula we will be using. So the integral of 0 to 5, the integral of 1 plus our y prime here, 2x squared dx. We will input this on our calculator. Wait. Let me get my calculator. So, the integral of 0, 5, square root of 1 plus 1, 2, square root of x squared. Oh, it's math error. Wait. Since my calculator says math error, I solve it manually. Our answer will be 5.64 units. We will now proceed to the surface area. Number 1 problem is find the surface area of a line x plus y equals 4 from x equals 0 to x equals 4 rotated about the x-axis. So it should be a line look like this. And then this will be our DL. This line is our x plus y equals 4. Here. From this to this will be our x, and the height should be our y. So let us extract our this. This thickness will be our DL. From here, be our y. One plus y prime is equals to -1. This is our y prime. D a 2 pi y dl. This will be our formula, and we will derive this. This is now equals to 2 pi y 1 plus y prime squared dx. So this is the formula of our surface area. So we will now input our y prime here and our y equals 2 pi. Our y is 4 minus x square root of 1 plus our y prime, which is negative 1 squared dx. And limits from 4 to 0. Our final answer will be 71.08 square unit. That's it. That is our final answer. And this is an example of a surface area. So we will now proceed to a centroid. We will now proceed to concept of a centroid. If we have a line here, let's say we have a line here, the limit is from A to B, and now a line here, and this will be our, let's draw a vertical strip here, and then a centroid is inside our vertical strip. It is here. A centroid is just a small dot on our vertical strip. So this will be our dx. From here to here will be our x. From here to here is the y of our centroid. From here to here will be the x of our centroid. And the height of this vertical strip is our y. That's it. Let's extract this. Our centroid. From here to here will be a y of our centroid. From here to here will be our y. A1 minus A dot. A dot is just total area of our centroid. So to derive, we have a y all over 2 y dx all over integral of y dx. That is our yc. Our xc is a1 minus xc, a total area, xy dx all over y dx. That's it. That is the formula that we will be using in getting a centroid. That's it. That will be the end of my master class video. Thank you so much, everyone. Don't forget to like, comment, and subscribe to my channel. That's all. Thank you.